Alright, in this video we're going to go over how to draw a normal line. A normal line is just a line that is perpendicular. It's an imaginary line, perpendicular line, perpendicular to a surface. Perpendicular or 90 degrees from a surface. Alright, sometimes we use this to symbolize perpendicular. So these are two lines that are perpendicular to each other. Alright, the way we can use our protractor to help us draw a normal line. If we look at our protractor, over for a second here. Alright, we'll see, here's our sort of central point. We'll be referencing that a lot. And we'll see it counts from 0 to 90 all the way to 180 degrees, either going around clockwise or counterclockwise the other way. So the way to help us draw a normal line, 90 degrees is the angle we want for that. And a normal line is always 90 degrees from the surface. So you'll see here, we've already drawn the normal line. At this point, we have a line here that is 90 degrees from the surface of the triangle itself. So to draw this normal line, what I'm going to do, you can zoom in here. I'm going to find that 90 degrees, this is upside down, on my protractor. And I'm going to line that line up here again as my 90 degree line. I'm going to line it up with the surface. The reason I'm doing this is it'll make the edge here, the flat edge of the protractor, that'll be 90 degrees. So 90 degrees between those two. And that's going to allow me, as long as I line it up real nice, to draw a pretty good normal line. So you can see again, here's my 90 degree line. And the normal line is imaginary, it's not a light ray or anything. So we're going to draw a dashed line so we don't think it's a light ray. Same deal here. I'm running a little bit out of triangle there, but I can still line this up. If you're struggling, you could always flip it around and draw it over here. Dashed line. Let's try out these other ones real quick. Feel free to jump a little. Try it yourself and jump ahead in the video if you just want to see what it ends up looking like. Or maybe you're going to have the solution document to check your work. And that one's a little crooked, didn't do the best job, but we're doing what we can here. You can also draw it going the other way too, into the surface. Doesn't just have to be out of the surface. Normal line goes all the way through. There we go. So that's how I can draw a normal line for a flat surface. So a surface that makes a line like the three sides of this triangle. For a surface that is curved like a circle, the normal line will always point towards or away from the center of the circle. So I have this semicircle here. This little dot's representing its center. So if I wanted to draw the normal line at the spot at the top, I could, I don't know why I'm using a ruler, I have a perfectly straight protractor here. All right, I'm going to line up the spot I care about, in this case this dot, with the center of the circle. So again, I'm just using my protractor here as a straight edge. So the same way I would use a ruler. All right, and the normal line points in the dimension towards or away from the center of the circle. Another one, this one's already done. If I wanted to, I could add the going in. All right, now these are not on the circular arc, these 2 points, so I'm not going to go away from the center. Again, I have this flat surface, so I'm going to use my 90 degrees again to help me draw a dashed line there. Oh, we're hearing an announcement. Okay, we're now over here. We're going to do this last normal line for this half circle. Similar idea here, except the circle's kind of been cut out of the object. But we can still use our idea. Alright, we can still use that idea that the normal line points towards or away from the circle's center. So there's my normal line. Again, I'm just using my protractor, not as a protractor, just as a straight edge to help me draw these normal lines. One more. There we go. If I was going to have a spot like over here, again, I would use the idea of using the 90 degrees on the protractor. All right, so that is how to draw a normal line from a surface using your protractor. We can again use the same idea. We have to place these poles, and we want to place them normal to the surface or perpendicular. Remember, normal just means perpendicular. Just a math word. All right. And I can use my protractor to help me draw, lining it up with that 90 degrees. Here we're drawing flags, so I'm going to draw those instead of dashed lines. It's a little tougher. I don't have a long line to line up with, but do our best. Now it looks like the center of that circle is just about there. Have to estimate that a little bit. Alright, there's one flag. There's another flag. And if you're like, Mr. How did you know where the center was? What if I put it somewhere else? As long as I see that you're going for that idea, you're going to be okay. I'm not going to expect you to be able to get it perfectly. Somewhere around there. This time I'm going to go away from it because the flag's on the ground. And yay, we're back to a flat surface. I'm able to use my protractor again. We're curving again. This looks like it's a quarter circle, so I'm going to say the center's right about there. Using my protractor just as a straight line here. Help me out. There we go. And we have one more flat spot here. So I can use my 90-degree line to help me draw a 90-degree angle. Okay. Last one I'm just going to sketch real quick. If you wanted to be specific, you could, this time we have the flags and we want 90 degrees. We could again line up our 90 degree with the flag this time and then use that to draw the line. These look like they're all on the same path there. So again, I'm using the protractor to help me draw that 90 degree surface. This is looking curved. I don't expect you to be able to freehand a perfect circle, so just kind of go for it. And then we're curving the other way. Back. Alright, what I'm looking for is if I look at your line, does it sort of look perpendicular to the surface at each of those points? These ones look pretty good to me. This one I didn't do the best job, but I've shown that general idea. Peace. Couple more normal lines here that we're also going to use to measure what's called the angle of incidence. Okay. So the first thing we're going to do is we're going to use the same procedure we used previously. to draw ourselves a normal line. So, refresher, I'm lining up with 90 degrees. I'm using the straight edge of my protractor to help me draw a line that is perpendicular to that surface. And let's just go ahead while we're here and do that for all of these mirrors. So we practiced drawing normal lines, now we're actually going to use them. We're going to apply them to starting to get the idea of how does light interact when it hits a mirror. So we have, this one actually is on the normal line there. What happens when light hits a mirror at an angle? What does it do? That's what this normal line is there to help us measure. It's just a tool to help us measure that. Alright, we're labeling the normal line, and we want to measure the angle of incidence. The angle of incidence is the angle between the incoming ray, so that's the ray that's going to hit the mirror. That's the word for incoming, is just incident. I just totally misspelled that, even though it's right on the page there. The incoming ray and the normal line right? And then we're looking specifically at the normal line at where it's hitting, where it hits the surface. Where it hits. Sorry, I'm left-handed. This is a video, you can always fast forward and pause things. All right, so how am I going to do that? I'm going to use my 0 degree mark, so that's on either side here. What I'm going to do is I'm going to take my protractor, I'm going to take this center piece. All right, everything's measured from the center spot where these two lines cross. I'm going to line that up with either my normal line or my my incident ray. I'll show both ways. You'll see you get the same result. Okay, so I'm lining that 0 degrees up right here. And then I would measure, where does my normal line end up? And you might be like, ooh, I didn't draw my normal line long enough. You can extend that if you want. A little bit of help there. Other things you can do is if you have another straight edge or a pencil, you can kind of put it right along the normal line to help extend it for you so you can see what's going on there. Right, but I've drawn it. All right, and be careful you're reading the right part of the protractor because you do have numbers at the top and the bottom. I'm starting from 0 here, and I'm going up to, it looks like halfway between 50 and 60. 55, I could count that over, and we got 55 degrees. So this angle, and you can mark it like this, 55 degrees. It's less than 90. Okay, so that's how I know I didn't pick the wrong numbers, right? If I had read this as 125, 125 would be way bigger. 125 would be more than 90 degrees. If we had gone the other way, if we had lined up this way, we would have gotten the same thing. Here, I'm going to be looking at the inner numbers, 0, and follow it along. You can imagine if I extended this ray, I'd get about somewhere halfway between 50 and 60. It'd be my 55 degrees again. So either way, and if if the rays are too small to see with your protractor, you can just, in some cases you can eyeball it, in other cases just draw the normal line longer, or draw, in this case I drew the normal line longer, so maybe you do this and you're like, oh, that ray's not long enough, just switch to doing it the other way, and extend one of the lines if you need to be able to see it on your protractor. And we'll do the rest of them just so we have it. Well, this one's nice. I don't really need to extend the line because I see it's ending up right along the line on the protractor that leads me right to 30 degrees. 30 degrees. Key thing here is we're not measuring from the mirror surface, we're measuring to the normal line. That's the convention that physicists use to measure these angles. This is one it's looking like I'm going to want to extend one of these lines. Why don't we extend the incoming ray, the incident ray, just as an example of how we could do that instead. So I'm going to extend that just because I don't want to hit all my text here. Line up our protractor. And I'm starting from 0. And I'm counting all the way to 70. 1, 2, 3, 4. Looks like 74, 75 would be a little bit more. 74 degrees. And if you're doing this and you measure an angle that's 1 or 2 degrees off from what I measure, that's fine. We're hand measuring things, so we might measure slightly different results, especially if you draw a line like I just did. That's not exactly the same. That's a little better. And again, here I just decided to extend the light ray. Here's 0. I'm always counting from 0 to 30 in this case. That's another one where I guess I didn't need to extend it. It was going to land right on the 30. This one's coming in perpendicular, so this is 90 degrees. We have our symbol for 90 degrees, right angle. And let's see, can I get this one without having to extend anything? Looks like it. It's lining up nicely along that line. Start with 0, go up to 60 degrees. We have our 60 degree angle there. All right, cool beans.